approach is basically abstract approach, and this approach is sometimes termed as asymptotic approach. Asymptotic approach. So what is the idea of this approach? Here we make use of pseudocode. Now the idea of pseudocode is used here. What is pseudocode? What is pseudocode? So pseudocode is the combination of natural language and programming language constructs like if statement, if else statement, switch statement, for statement, while, do while, etc. So these two are basically branch instructions. These three are branch instructions, and these are iterative instructions. Fine? To deliver the main idea of a given problem, to give the main idea of solving a given problem. So pseudocode is very easy to understand because it involves natural language, and it includes certain programming language constructs to give a taste of, to give a flavor of programming language. Fine. So it is not entirely the natural language and it is not entirely the programming language, but it is a combination of natural language and the programming language that makes it a better choice over the experimental approach. And what could be the benefit of this? Let us understand that. How we can write a pseudocode and how we can derive the time complexity for a given algorithm through this approach. So the basic structure of pseudocode, is that we have to first write the keyword algorithm, and then we have to write pseudocode name. We have to provide certain parameters here. We have to define certain parameters here, and inside it we have to define input that is to be taken in the algorithm in terms of the parameters. Fine. Input taken in terms of parameters. Then we have to determine the output as a solution, and what solution is to be obtained. And finally we have to include explanation part. So that is the basic structure of pseudocode. Fine. Now let us write a simple pseudocode to understand how we can determine the complexity using the asymptotic or the abstract approach. So here what we can do is, let us write a program, let us write a pseudocode to find out minimum element from a set of n integers. So what would be the pseudocode for that? Let us check that. So the pseudocode would be algorithm, and the name of this pseudocode is min element. Fine. So you have to make sure that the name of the pseudocode must be very much familiar with the problem that we are designing. Fine. So it must be very close to the problem we are defining, so that it gives an idea that what actually we are doing. Fine. And the parameters that I want to take is a and n, and I have to define these parameters under input section, where a problem or an array a of n integers are taken. And what would be the output? The output would be sorting of finding minimum element from n from array of n integers. So how we can write the program for it? How we can write a pseudocode for this? Let us understand. So we can take the very first element and put it into a sum variable min. So let us check that what exactly this instruction means. What we have done, we have taken the very first element of the array and assigned it to some variable minimum. This is a way to assign the value to a given variable under pseudocode concept. Fine. Under pseudocode concept, whenever you are supposed to do the initialization, you have to put the arrow in this direction. Fine. So this implies this element has been assigned to this variable minimum. Now we can run a loop for 1 to n minus 1, for 1 to n minus 1 do. So we have run the loop do if minimum is greater than an. What we can simply do? We can make an as minimum, and finally print minimum. So this is a algorithm. This is a pseudocode for the given problem. So how we can find the time complexity using this approach? Let us check that. So if we look at let us first understand how we can find the minimum element for the given algorithm. You can check that, suppose I have a list of integers, suppose 2, 4, 3, 10 and 1. So what is the minimum element? The minimum element is 1, but how we can use this pseudo code to find the minimum element? So we can see that that we have put the very first element into the minimum element, and we have checked that we have run the loop from 1 to n minus 1, and this is used for the comparison. Fine, we have to do the comparison. Since we have already taken the first element as a minimum element, so we have to start our position from 1, because array start from 0, 1, 2, 3 till n minus 1. So this element is already taken as a minimum element, so we have to start our comparison from first element. So we will move to first to n minus 1 element, first to n minus 1 element, and what we have to do, we have to find on each comparison that whether the minimum element chosen by us is not greater than an. If it is greater than the an, that means this element is smaller than minimum element, and we would then assign that element as a minimum element in this minimum variable. So if we keep moving with this approach till n minus 1 element, we would be in the position that we obtain the minimum element from this given array of n integers. So how we can find the time complexity of this pseudocode? Let us check that. So what we can check here, that this step would require one time. It just simply requires for one time to execute, and this can be written as in a programming form something like I is equal to 1, I is less than equal to n, I is less than n minus 1, less than equal to n minus 1, and I plus plus. Fine. So we can break this statement in this form as a programming approach. So this step would take one time running time, this will take n time to run, and this will take n minus 1 time to run. So if we add this, we would obtain 2n. So it will take 2n time to execute. Fine. And this step will take naturally n minus 1 time to execute. This step would be executed n minus 1 times. Fine, it would execute n minus 1 time, and this step will again, since it is inside the loop, till the time of the comparison, it will run n minus 1 times, and finally this will run only for the one time. Now we can add all these obtained running times to obtain the number of operations involved in this entire pseudocode. So this would be cancelled out here, this would be cancelled out here, we are end with 4n. So 4n, this simply means we require 4n operations to find out the minimum element from the given n integers using this pseudocode. So 4n is basically the number of operations. So how we can find the running time? Let us check that. So the number of operations that we have obtained in our previous example is 4n, and the running time that we would obtain would be n. Why? Because running time is directly proportional to the number of operations. In pseudocode approach. Fine. So if we have the running time as 4n plus 6, it will also give us n. If we have 3n plus 5, still we have running time as n. It simply means in generalization we have an plus b and still we obtain the running time as n. This means that whatever the value of the a or b, it wouldn't affect the running time of the given problem. it will always give us the value as n. Similarly, if the number of operation is 6n square plus 2n plus 1, what would be the running time? It would be n square. Fine, it would be n square. So we have to take the highest power where power n as a running time of our given pseudo approach for a given algorithm. Fine. So we have to consider the worst case situation as a running time for a given algorithm using abstract or asymptotic approach, and this gives us an approximate time. Fine, this is an approximate time, not the exact time. So using this approach, we basically obtain the approximate time for a given problem. Fine. So what are the basic characteristics of pseudocode is that so what we have understood here, main points, that running time is obtained as number of fundamental operations required to solve a problem, or to solve a problem in a given algorithm. Fine, very important point. So we have to remember the number of fundamental operation. What could be the number of fundamental operation? It can be assignment operation, it can be arithmetic operation, it can be relational operations, it can be conditional operations. So all the kind of the fundamental operation we have to consider for determining the running time of a given algorithm under this approach. And second thing is that it gives us approximate running time for a given algorithm. So that is the basic idea of abstract or the asymptotic approach to determine the running time of a given algorithm. And what are the benefits that we have obtained here as compared to the experimental approach? The first benefit is that it is not dependent upon processor's speed. Fine, it is not dependent upon processor and its speed. Second thing is, it doesn't require any programming language, rules. Fine, it doesn't require any programming rules to define the algorithm, to design the algorithm. We just require, what we actually require, we just require pen and paper to design, pen and paper along with our logic to design an algorithm. So it is a simple approach to design an algorithm for the given problem. So we can understand that out of the experimental approach and the abstract approach scores over the experimental approach in the sense that here we don't require any processor, we don't require any programming language, hard and fast rules. We simply require pen, paper to design the algorithm for the given problem. So this is all about the running time, determining the running time of an algorithm. Fine.